Well, hello everyone. Welcome. It is December 18th, 2023, and we are going to do a stream today making some benchmarks. Who's ready to make some benchmarks with data frames? I mean, I love them. You guys should love them too. It's going to be a lot of fun. So if you're in the chat stream and you want to, or you're watching on YouTube and you want to join the chat, hop on over to Twitch, which is where the chat is going to be tracked. So let me test it. Test chat. Okay, it's coming up there. David J. Jackson's here. Thank you for hanging out. Also, LCKYN Lincoln, thank you so much for resubscribing for 1 month. You've been subscribed for 12 months. That's exciting. It's been a year of you with me hanging out, streaming sometimes more than others, but it's nice to have a day stream for me just in the middle of the day and to hang out with you guys. It's going to be a lot of fun. So without further ado, as long as you can hear and see me okay, everyone will let me know if that's an issue. Without further ado, let's just hop on over to showing my screen. There we go. All right, so we're gonna make an to-do list today. So the thing is, I want to test out the speed of some different data frames that they have. We have now in Python. It used to be years ago, back when I started, in the good old days, there weren't that many options. If you wanted to wrangle data, if you wanted to mess around with data, and it was like spreadsheet type of data you want to mess around with Python, you basically just use Pandas. But now we have some other options. You could use PySpark, you can use Polars, and recently, let's see if it's here. Recently, Rapids AI has released their recent update. Now, this is not brand new, but it's something that they added just this past month. Let's add the dark mode, which is the ability to now natively run Pandas code directly onto your Pandas data frame, or directly using Pandas and not having really to do anything else other than run a command in the top of your code. Now, there are some caveats to that, but we're going to learn that as we go. So I was thinking I'd like to make an official YouTube video about this, but I haven't gotten myself together on it. And maybe during the stream, we can sort of get there where we can benchmark some of these. So I'm going to turn off, make sure I turn this on localhost. I'm going to make a new notebook, and maybe I should switch to this view. I don't know if this view is better. You guys tell me which view is better. Actually, I like this all view because then I can pull out my chat, which is here. We can see what you guys are saying. We got some first-time chatters. Hello, welcome everyone. Thanks for hanging out. Thanks for hanging out. Thanks for new followers too. What's going on today? We're about to talk about that, Toby. So let's check it out. Let's save this as Python data frame benchmark 2024. I know it's not 2024 yet, but we're basically there. Like, everyone's gotten their Spotify Wrapped. So that basically means this year's over. If you've already gotten your Wrapped for like Spotify and YouTube and all that stuff, oh, look at this. My water is clear. Then I mean, essentially the day's over, or the year's over. Okay, so we're gonna do we're going to make an extensive data frame library benchmark testing. And the ones I want to test are Pandas 2.0 with PyArrow. So we've done this before. I've done this on some other streams and videos. but I want to compare these all side by side. We also have polars. Yeah, with our Python API. So we're going to run the Python version of polars, even though polars is written in Rust. And what else? We're going to use Pandas plus cuDF. We're going to see how things compare. So what's on our to-do list? I think number one, we need a good data set. So let's say gather data set. One thing we want it is to be large. It needs to be like at least a gigabyte plus. So if we're working it with a Pandas data frame or sorry, with a data set, not necessarily Pandas data frame, but any sort of data set that's a few megabytes, I don't think any of this stuff that we're going to be talking about today is really relevant, because you don't really care about the speed if it's 0.0001 second to run something or 0.00001. Add more zeros to the computation time. What we care about is when we have kind of large data and we're going to do some manipulations on it that we want to compare. So we need it to be large, right? We need it to have different data types, maybe dates, numbers, ints, floats, be more specific. And we also want maybe string values, right? So that's number one. Number two, make sure we install load latest of each library. And then three, create benchmarks to run and test. Let's test each. So we might have to create different environments to run each of them in, but we're going to start with the data gathering and we're going to go from there. Does that sound good? How does the chat think about that? What does the chat think about that? How about the New York City taxis data set? That's one. I want it to be original. I have an idea of a data set we can gather that I've basically already done some of the gathering. That's what she said. What I don't know what you're, PyArrows is Pandas 2.0. Yeah, Pandas 2.0 has PyArrow backend that we're going to use, because I guess we could add the original Pandas here, but we're doing modern stuff. So with Pandas 2.0, if we go to Pandas 2.0 documentation, they're already up to 2.1. Getting started. Let's see if I can search here. PyArrow. PyArrow warning this. Okay, so it's still experimental and the API can change feature release without warning. But this PyArrow backend does things a lot faster than if we were to do it just in straight, like the original Python series types. So it's, instead of using NumPy in the backend, it's going to be using PyArrow. So what do companies that work with terabytes use? I think it depends on what you're doing, but with terabytes, PySpark, I know Spark is kind of a big leader in that area, but we're gonna be working with kind of medium data here. What am I doing this for? Fun. Not a dumb question though. That's not dumb. That's an honest question. I'm bored of making projects by looking at videos. When I want to review a project myself, I cannot find exactly what I should look for and which columns I should work with, and eventually results burn out. How do we find what we're looking for in the gaming space when starting a new project? how do you automate this? I don't know if you can automate it sounds like you're asking a question about the creative part of creating your own project. I don't know if you can automate that part. But I'd say just start with a data set that you find personally interesting and then work from there. If you're trying to make a portfolio project, and you're finding yourself burnt out every time you're trying to create something from scratch, try to pick a data set that's interesting enough to you that you don't get burnt out with it. And if you do, maybe maybe need to reevaluate what you're working with. I don't know. Hope that's a helpful answer. Okay, so let's start with gathering this data set. We do want to gather a large data set, and I had already kind of started with this and actually I think I asked ChatGPT a good example of a large data set to use. And what I came across was this. Let's open a new tab here. So let's go into my repos. I think it was 70 Medicare data. Okay, so this Medicare physician or practitioners by providers 2021.zip. Each of these, it's not that big, but I think once unzipped, it's going to be much bigger. And let's learn about this data set first. Medicare physician data set. So this is provided by the data.gov. It's just freely available if you guys wanted to look for Medicare and physician other data sets. And it looks fairly large. It depends on which one we're going to use, but all I did was I went to this download section, and then I guess we could choose the starting date. It goes all the way back to 2013 and all the way up to 2021. Why does it start 2021? This data isn't that large though. So it looks like there's a bunch of different versions of this. And I don't know that much about Medicare and exactly how it works, but I do know this is a fairly large data set. It's an Excel file. Excel file. We want CSV. I know I downloaded CSV before. Public use file, free. I think it was all free when I downloaded it. Okay, so you can export here as a CSV. I don't know what the CSV for Excel is, but I believe I've already done this. There's over 1 million rows, so that's good. And we could load up the data dictionary to really get a better idea of it. But does this have as people's names? I think it has the doctor's names. Let me zoom this in. And then it has like every Medicare claim that's come through, I believe. Does that sound right? What's wrong with Excel files? They're not compatible with PyArrow. So it depends. I mean, nothing necessarily wrong with Excel files because you can use Excel Reader, but Pandas does read Excel files. I'm not sure about the other ones. And there's just a lot of complexity when you get into all the stuff that Microsoft does when it creates that Excel file. It's storing all this other metadata about the data in the spreadsheet. And when you're working with data this size, you usually want something like a CSV. It's just like the cleanest slate you can work with. So let me check here. I downloaded these Medicare physician, other practitioners and providers zip files for full years, 2017, 19, 20, 21. Why didn't I get 2018? And then here's an unzipped version of one of them. And you can see it's about 50 megabytes. So basically all I need to do is just unzip all of these. So if I unzip Medicare provider 2020, and then unzip I guess this one has a data set in it, 2017. If we combine a few of these, I think we're gonna have a big enough data set that it's gonna be good to work with. And then we're gonna do 2019. All right, so we have this data here. I guess we can make a directory called zips and make a directory called zips, move all our zip files into that folder because we could probably delete those. And let's make a directory called data and move all of our CSV files into that. I also think, let me just check here. Let me just check over here. I think I downloaded an even bigger file. Yeah, so let's move this downloads Medicare provider in service 2021 to this directory. Yeah, so this is other practitioners by provider, and the larger data set is practitioners by provider and service. So I think that means what they actually performed, like so let's unzip this one too. See how big this one is. I didn't look to see if there's dates in this. It would be ideal if there was dates. There were dates. All right, let's move this Medicare zip file into our zips directory and move the other one into our CSVs or data directory. Got it. Okay. What do you guys think so far? Do you have any advice? New Kaggle competitors with intermediate machine learning knowledge. Get started on one of the competitions that's out there. Unfortunately, right now, there's not a lot of competitions out there, but at least not a lot of ones with medals that I've noticed recently. That may mean that there's a bunch coming out soon, but it could also mean that you could work on one of the, I think they have fun ones that they release every month, and the winners get swag. It doesn't necessarily result in you getting like points on Kaggle, but most people don't really care about that much. And yeah, you should check that out. Oh, I changed my name. Yeah, I changed it. I changed it to something a little bit more easy to understand if you don't know me. All right, so I'm still old school, and I'm gonna use Pandas just to explore the data. So we've downloaded this large data, but I kind of want to create a big combined file. Let's try to make it into Parquet format, because all of these will use Parquet, and Parquet is a nice way of keeping all the data types intact. So let's go ahead. Actually, let's use glob to list all the files we have in this directory. So it's actually, I think, this Medicare data directory, and if I use the star, it'll then just list all the files in this directory. So we have 2017. I really wish I got 2018, but oh yeah, I also want to check the size of this larger one. Yeah, so this larger one is only 1 year of data, but it does have, it's 3 gigs of data. So that just by itself might be good enough. Let's see which one that is. Yeah, it's by provider and service. So let's just take that as our example data frame. We are going to read that CSV as DF, which is data frame, right? And let's just see how this goes. Let's make this a little bit smaller so we can see more of what's going on the screen. Let me know if anything ends up, I cover anything with myself. I can make myself smaller. I can also make this text a little bit more hidden. It's going to take a little while to load because this is 3 gigs of data as a CSV. In memory, it might actually be a little bit larger. Are you testing query times? Yeah, we're going to test some data manipulation times. So we'll do things like some group by operations, some like calculating minimum, maximum values. Parquet is binary and therefore smaller. Yeah, Parquet is a compressed version where we can store the data. Okay, so we see this already, that we have a data type warning because some of these columns have mixed type. So if I do df columns on this, we can see all the columns in this data frame. What's the length of this? 29 columns. And I think if I go to column 11 and I select that, so this looks like it's mostly integers. Yeah, so look at this. It gave this warning about this column because this is supposed to be a state code. Let's see what this data dictionary will tell us. Data dictionary. Let's view this data dictionary. All right, so we look up this one column. It's telling us this is the FIPS code for rendering a provider's state. What is a FIPS code? So I guess there's this text file here that has a list of all the FIPS code. It's a census code. So it's a number between 0, 1, and 78. So I guess there's more than just the 50 US states. There's some extra stuff like Micronesia and yeah, does it have Puerto Rico, stuff like that. But in this data file, we don't only have numbers. So like we did a value count on this. The most popular state is 9. Was that California? Connecticut. Oh. No, 6, sorry, 6, which is California. Yes. Okay. But there's also like 9C, 9A. So this is not an integer. So what it tried to do when it was loading in this data is it tried to load it probably initially as an integer. And then it realized, oh wait, this actually can't all be integers because there's sometimes a letter in there and that doesn't really mix well. I don't know what 9C, 9A is. I bet that's like the state 9 with some sort of other caveat with it. Whatever. Okay, so let's look at the info of this and then we'll save this as a Parquet file. All right, so it's over 2 gigs in memory. That's pretty good size. We have mostly float, int, and object columns. Do we have any dates? It would be ideal if we had dates. If not, you know, that's fine for now. But I don't think we have any dates. Aren't they going to tell us the date that the... Wouldn't it make sense if they showed us the dates where the transactions occurred? We could just put dummy dates in there. Let's do this. PD set option. Display... max columns. Do this a lot just so we can see all these columns. Let's run a head command on this. Nope. I don't see any dates. Payments amount. but no dates. Okay, so we're gonna have to do without dates. That's fine. So it doesn't really tick all the boxes and what we're looking for, but okay, so let's take this. Should we format any of these columns, like automate them? Maybe, or sorry, convert them from strings or objects into something else before we do this. Maybe we could do that with this. I think this is the provider gender. Looks like that's the name of this column. Yeah, if we do a value counts on this, this is probably going to do better as type category, because there's only 2 values in this. It doesn't need to be a string. All right. First name and last name, those are actually going to be unique enough, I think, that we don't want to do that. The credentials. So this could be, actually, there's a lot of different credentials. I thought there would only be a few, but if we do number unique on it, it's over 16,000. I guess we don't want to do it on that. Provider type, maybe provider type is something to make categorical. This could be a Boolean too, potentially. So keep that in mind. So do a value counts on this. 103. That seems like a good one. I don't know if there's no real exact science to this when you decide to make something categorical. Kind of depends on the size of the data and what you're trying to do with it. Hi, Rob. Hey, Skyrazor. How's it going? Why don't you create a data frame using random variables? I could. I just like to use real data. I think it makes it a little bit more interesting. I could, though. Let's see if this can be a Boolean value, because that would be nice to have an example Boolean. It won't work if there are null values, but it looks like it's all Y or N, which is good. So what does this column even mean? Identifies whether the provider participates in Medicare and or accepts assignment of Medicare allowed amounts. The value be Y if provider had at least one claim. Why would it be in this data set if they didn't accept Medicare? Okay, so we're going to replace Y with true and replace N. What is it? Was it Y and N? With false. And as type bool. Let's see if this works. All right, so now we have a Boolean column. We have bool. Let's also load this. Jupyter Black. Boom. Boom, 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 boom. Now that'll format that a little bit better. If we run another info on this, it's going to be smaller. 1.9 gigabytes. Okay, we've reduced the data size slightly, but that's not what we're here to do. We're here to do some benchmarks. Import seed. Okay, warriors, you're telling me how to do random data. Yeah. I want this real data though. Yeah, we could do random data. But I don't wanna. I wanna do what I wanna. Okay, so we're gonna make Parquet file with this data, and we're gonna call it probably something similar to this. The original name. Yeah. All right, so I'm gonna save it there as a Parquet file. This might take a few seconds, but if I now go into our benchmarks folder, Oh, it's failing. Why did it fail? Sometimes it doesn't like certain data types. Expected bytes got an int object. Conversion failed column. Okay, so it doesn't like this column. That's the same state FIPS thing that we had before. So let's force this to be a string. Actually, if we do a value counts on this, we could maybe make this 116 values. We could make this one a category too. I think that'll save Parquet from letting us save it. Let's try this again. All right, so we can delete some of this. See if it failed again. Cannot convert. Okay, still doesn't like this. So this should be a object type. Could not convert 01 with type string. Tried to convert to int 64. This is an object data type, but these are staying as. If I make them all strings, and then as type category, now it doesn't try to make these as integers. The 01 stays as a string first. So let's see if that works. So first convert it into a string, then make it categorical. Then do all this stuff and save it as a Parquet file. You could impute year by file and concat. That's a good idea too. Year would still just be an integer though. We wouldn't actually have a date. I can make fake dates like we talked about before. All right, so why can't it convert this value to an int? So now it's having issues, and this is pretty common, especially when trying to save as Parquet files. So one downside is because the Parquet file actually stores the data types of each column, then if the data types of each column in Pandas are not perfectly convertible, it's going to throw an error here. So I'm guessing if I try to convert this to an integer, it's going to give me a problem. Yeah, so we have some values here where this is supposed to be a zip code, but for some reason we have a value M3B1. So I think we can do errors here. Ignore raise. Let's see what the options are. Errors, raise, or ignore. I think this might cause us more problems down the line. Yeah, so we're trying to convert it as an integer and it's staying as an object. Let's sort these values and see if we can see. Oh, see, it doesn't even like that. Same thing as databases, right? If you have a database and you set the format of the data type of a column as an integer and you try to throw a string in there, it's going to give you an error. So that's sort of what we're dealing with here. Hello, Rob. Are cases like the one you are showing also represented in the job market? Yeah, having a good idea. I mean, being able to work with data in a data frame format is almost essential if you're going to be working as a data scientist or an analyst. So these type of skills are pretty useful. And even if you're not doing that type of job, I think these are very helpful skills for you to learn for whatever you're doing. But I am a little bit biased. Look at some of these zip codes have like one example. All right, we have missing values. I'm just trying to do a value counts to see. I think we might just want this zip code to turn into being a string. Our other options are to take this zip code column and to take this zip code column and try to find all the examples where it's not integers, because it obviously should be. If we look up in the data dictionary, what should this be? The provider's zip code as reported in. So they probably just fat fingered when entering in the values, and there were no checks on the Medicare whatever system side. So let's just convert these to string. All right, let's see if this solves our problem. We just want to save this as a Parquet file. Could have also done low memory equals false here when we load in the file. This will allow the data frame to have different. I think it will just basically force it to a string type representation for any columns that have mixed data types. All right, so that worked. Now if I go here and I look in this directory, data frame benchmarks. Oh, it's actually in this Medicare folder. We can see it's 406 megabytes on disk. That's a good size, but locally, once it's loaded into memory, it's about 2 gigabytes. Make sense? Everyone good? We're about to run some benchmarks. Why convert zip code to an integer where the zip codes with leading zeros? That's a good point. That's a good point. You can format them to have leading zeros, I guess, even if they're an integer, but that's a good point. There are some zip codes with leading zeros. Imposter engineer. Keeping me in check. Okay, I'm going to quickly run to the bathroom and then I'm going to come back and we're going to do some benchmarks. Let's do this. Be right back. Whew. Did you miss me? Okay, back. We're ready to do this. We've gathered some data. Now we're going to do some benchmarking. I am back. Okay, I mentioned this before, but we're thinking about doing three different types, right? Pandas, polars, Pandas 2.0, polars, and Pandas plus cuDF. So what that'll allow us to do, what cuDF will allow us to do is run on the GPU. So we'll kind of get an idea of that. But we need to make some benchmarks that we're going to test. What do you guys think would be some good benchmarks? Are we going to use light SQL? SQL light? No, we're not actually going to use any databases because we want to test, like, if you're running data manipulations locally on some file that can fit in your computer's memory, what are some of the options you have? And those are, we're not going to dive into using databases. So what I just did there was I reset the session. So now we're starting with a brand new session, and let's do import pandas as PD. And let's just test. Let me also print pd.version so we know what version it is. 2.1. Now we read as Parquet. How do we, I think they changed how we do the pi arrow backend. So here's the documentation for Pandas 2.1.4. We have 2.1.1, but I'm assuming it's going to be pretty simple. All right, we can set the data type using float and then pi arrow. Is there a way we can make it when it reads a Parquet file? Used to be that you do pi arrow backend. So we could set all the data types. What about when we read Parquet? Okay, so they say, okay, we set the engine to pi arrow. Maybe this will do it. We have our Medicare data Parquet file, this really big named file. And our engine is going to be pi arrow. Does not like that syntax, probably because we have multiple commas here. There we go. Let's see if this works. While that's running, I might as well get this stuff back in. All right, so we have the data frame in here. Let's run a head command on this. All right, we need this a little smaller. All right, head command on this. We have a bunch of different data. The shape of this is, all right, pretty large. We almost have 100 million rows and 29 different columns. Let's see the data types in this, because when I ran this with the engine pi arrow, I would think these would be loaded as pi arrow backends, but I don't think they are. Right? So this is just an integer. If I do as type int 64 pi arrow, will that change it? It will. So I don't think the engine part works. Pi arrow backend, specifically setting the parameter to dtype backend. Okay, so maybe I need to set dtype backend when I read this. Let's try this. All right, it looks like that ran a lot faster. So I'm guessing this is the pi arrow backend. Yes, okay, so now it's automated this into PyArrow backend. It also has these PyArrow dictionaries as some of the stuff we set as categorical. Like this. Yeah. Yeah. So everything just feels a lot faster too because I did that. All right. So let's make some benchmark experiments to run. Hey man, I knew this was on. I just joined Twitch to see you code live. Thanks, Manish. Appreciate that. Lambda functions, would that be engineer? All right, so let's do this. Let's see. I think these are unique, these values. No, they're not. So part of it is we don't understand this data set, or I don't understand this data set very well. So we're kind of learning as we go. But rendering NPI, the national provider identifier of the rendering provider on the claim. The provider NPI is a numeric identifier registered. Okay. So some of these NPIs have about 600 rows in this column, but that's still not very much when you consider how many values are actually in this data set. I want to take something maybe like the address. Let's also set this again to display more columns. Read that in. Okay, here's an idea. Let's just do something and see if it makes sense. All right, so we have the provider's credentials. So this is like if they're a medical doctor or practitioner, I don't know, a bunch of different options for that. So we can group by that. And then let's see if we can get some statistics on the amount of money requested for that. So total services, total bennies. I like that, bennies. Average submitted charge. What does that mean? Let's look that here. No matches. Average of the charges that the provider submitted for the service. Okay. So if we group by these credentials, and then we take the average charge and do a mean on this, it should give us, and then sort values. This should give us for that number or for that type of practitioner, what the average claim is. So this family nurse practice averaged $3. Is that in US dollars? Oh, number of charges. Okay, that's the number of charges, not the amount. Dataframe average charge. So this is computing the average charge on this. And if I do a time it with this, we can actually let this run a few different times on this data frame and see how long it takes to create this. All right, half a second roughly. 4.14. All right, so I'm going to call this test number 1. Average. It's our group by average. Hey man, I was just okay. That's Manish again. All right, so let's do it in a different. Let's do it some way different. All right, I'm gonna reset this. So this is Pandas with PyArrow backend. Let's see how much this takes with, just to get a benchmark, a baseline. Let's just do Pandas. Let's just do a benchmark with the NumPy backend. So basically, we'll read this in without this D-type backend as PyArrow. And of course, I need to load this again. We can see that even loading it in is a lot slower. All right, so that's about the same amount of time. Shouldn't it give me this? Oh no, maybe I haven't actually run this yet. What in the world? When you run time, it does not actually save this? All right, so it doesn't actually do the save. Let's do this. All right, this is just a float 64, so we know that it's using the NumPy backend. This actually wasn't that much faster using the PyArrow backend than just using the normal NumPy. We could see what time it has done here though, right? It's run 7 times. It's tried to do this operation 7 times, and it's timing on average how long it takes and then the standard deviation. So it's pretty consistently around 427 milliseconds per run. Any Kagglers who plays Dota? Not me. All right, so comparing that to the PyArrow backend. So we're gonna do this with the read parquet PyArrow. I reset everything. We need to import pandas. And then we'll run a time it on this. Okay, slightly faster that time. It'd be interesting if we add a lot more columns. Maybe that'll change. All right, so we've tested 2. Baseline pandas, Pandas 2.0. Now let's try cuDF pandas. This is what I'm really interested in seeing. So this will actually load the data frame into my GPU's memory. This you can only run if you have an NVIDIA GPU. It's just the way it's set up, but it's going to be leveraging one of these GPUs to run the computations. So let's go over to the repo and remember how exactly we need to do that. Now, actually to do this, I think I've installed this into a different Conda environment. So I actually have to select my special cuDF Conda environment where I went through these steps to install cuDF. They have it listed down here, I think. Install instructions. All right, so apparently all we have to do is run this load extension cuDF pandas, and now pandas will be running on the GPU. Hopefully. Ah, no. No module named cuDF pandas. Maybe this was called, maybe it's this Rapids one. Okay, so there's no Rapids one. Let me see. Rapids 2310. You can see I'm keep very good track of my Conda environments. You have an RTX 6000? You envy me? Yeah. Yeah, it's pretty sweet. It's pretty sweet. I'm not going to lie. I swear I ran this before. Cplex, ChessViz, Betty, no. Let's see when okay, let's go back in time and try to remember my Conda environments. Conda env list. This will list all my Conda environments. Could be this one. I actually think it is this cuDF version. So if I go into Conda activate, let's test. I think there's a test to make sure I have this installed correctly. Okay, so I should be able to test by just loading in cuDF. See if that works. So that does work. I did install that correctly. Import pandas as PD. Pandas version. Now here's the thing. I think cuDF only works with Pandas 1.5. So it's not going to work with Pandas 2. It's not supported. But this automatic running on the GPU requires an older version. Now it's still no module named cuDF Pandas. November 19, 2021. That's an old error. I'm in this cuDF Conda environment. Let's try to install it. Installation, we need to install Rapids AI, cuDF 2402, Python, Cuda version. This is with Conda. All right, we could risk it. It might have been an issue when I upgraded my Cuda version. But let's just go here and double check. Stable release, install. Home, okay. Installation guide. With pip. I'd rather install with pip. All right, copy this command. This could be a little risky, but let's try to install this here. Because if I look at the cuDF version that I had installed, it's 23.12.01. It's pretty recent, right? Depends on the model. Does anyone know if Spacey Library works well on GPUs? I don't know. Have I imported cuDF? Yeah, I did it right here, right? I imported it, cuDF, pandas version. Then I try to run this extension and it's saying that cuDF.pandas is not installed. So I'm trying to now use their instructions to install it. The thing is that this is some of the stuff that happens when you're running on GPU is you need to make sure everything lines up. So our Cuda version is 12.2 and I see in their installation instructions they support 12.0. So is my Cuda version too new for this? Also works on Python 3.10. And if I do conda activate cuDF Python, yeah, I'm on 3.10, so that should be good. All right, so let's look and see once it's done running. It's downloading DAS, cuDF, QML, cuGraph, going cuckoo for Cocoa Puffs. Anything else you guys want to talk about while this is going? People are here. People are watching. We're having a good time. All right. Actually, while that's downloading, let's do the polars version. And I might actually need to update my polars because it's been a while since I used that. So I'm going to go back to this Kaggle 2023 and import polars as PL. All right, so that's not installed in this. Hoof. Default kernel. All right, so polars is installed here. PL print pl.version. $19.10. And let's look on their website and see what the latest version is. These websites look so ugly when I try to use them in dark mode. Okay, so latest release right now, 20.1, 19.10. So while that's going, activate Kaggle and then pip install upgrade polars. I think that's all I should need to do. And we will also upgrade our polars. All right, uninstalled 19.10 and install 20.1. Restart this. All right, now we have polars. And we're gonna do scan Parquet to this file. So we're basically gonna try this exact same thing, but we're gonna do it in a polars format. So scan Parquet. And then we're gonna call this our data frame. Group by. Polars has this group underscore by. Of course, got to be a little bit different than everyone else. We'll group by this. And we'll aggregate. And we have to select this column, which is the average submitted charge. And then mean. And this is going to show us what it does, okay? And we have to execute this. run. All right, let's actually do this because I'm lazy. Here, let's do this. No. String formatting. All right. I'm asking something to convert this code from Pandas into polars. We're gonna see how this works. There we go. Doing a lot of things at once now. I had so many problems with Conda while working with something like RASA, always going with Python, V and yeah, virtual environment. Yeah, I need to test out virtual environments again. It's been a while since I've actually used it. But it could be a better alternative for some of the mess that I have going on here. As you can see, I had a bunch of environments already set up, so it was sort of easier to use those. But yeah, maybe I need to switch over. Okay, so this is our group by aggregation now in polars. This is how it's saying how to do it. It's going to sort values. Okay, we sorted that. And then if we have this average change data frame and we run a hang head on it. All right, so we're going to just read Parquet, not scan. Compute this average change. Run a head command on it. Okay, now this looks like what we had before. And I'm going to run time it on this. Remember, our baseline is around 372 milliseconds. So with this, polars is about the same. Yeah, so it's about the exact same using polars versus pandas. It's actually surprising because usually it was a lot faster. All right, so this is done installing for the cuDF version. Let's see if we can get that working. All right, now we're into the cuDF environment. Print our pandas version and our cuDF version. We'll try to load this extension. Module not found. Maybe I need to remove this. Oh, was that it the whole time? That comment there. It was just that comment. I'm an idiot. All right, so now we're in our cuDF environment. I'm completely starting from scratch. And let's try running. We should be able to run the exact same pandas code. Now we can't use the PyArrow backend because it's pandas 1.5, but we can load in this data frame. And now I believe it's going to run everything on the GPU. So starting over from scratch, just so we get the same timing down, we're comparing apples to oranges, just apples to apples. Reloading this, we're not timing how long it takes to load in. And we're timing the average amount of time it takes to run this group by aggregation. Now look here, my RTX 6000 is actually running because we have OBS. That's the main thing that's running. Okay. The other thing it's running, I believe, on the other GPU, maybe on both, is this run. Okay. So 16 milliseconds. That's a lot faster, right? So now that we run it on the GPU, it's actually look, it actually ran so much faster that time it decided to run 100 loops each time it tested of the 7 runs. So before it just ran 1 loop each, but it's actually 16 milliseconds to run the same code. So that's a decent speed up. Granted, it ran on the GPU, so we need to keep in mind there's other stuff going on in the GPU. Like I'm running OBS right now that's taking some of my GPU resources, but yeah, that's a significant speed up. Could you please give a harder task to run in this? Yeah, let's do some other tests to really compare. Okay, so that was just test number 1. Let's do a test number 2. Again, we'll start from scratch. We'll do this in normal Pandas 2.0 with the NumPy backend. Make sure I run these each as so we're gonna run this and load in our same data frame like we did before. And we have to change our environment back to my default one. Let's try to stress test this. Let's try to really push the limits of what we're doing. Let's try to make something that'll take a few seconds to run on this. So what I'll try to do is let's group by something that actually has high cardinality. So we know this provider credentials has a lot of unique values, right? It's like 16,000. So we'll group by that. And what else should we group by? The provider gender. So we're going to group by 2 things now. And then let's take multiple columns that we have here. So we have the total benefits, total services, total benefit day services. Basically every numeric column, let's try to take. Average submitted charge. Let's just do this, df columns. And these. All right, so we're grouping by 2 different columns. We're going to take data of 1, 2, 3, 4, 5, 6 different columns. Then we're going to aggregate and take the mean value, the min value, the max, the standard deviation. Is that enough? Joins may hard to compute. Yeah, you're right. And we're going to call this data frame aggregation. That actually seemed to be pretty quick. What if we then unstack this? And we fill NA with 0. And yeah, let's just do all this stuff. All right. Let's also format this using Jupyter Black. Just want to make it look pretty. Hey Ralk, welcome back to chat. Long time no see for sure. Pivot table could be interesting. That's essentially what we're doing here with the group by and unstack. Okay, we're going to do all this group by, unstack, fill NA, all these different columns, just to make sure it works again. Now it looks a little bit cleaner. Let's also pass this. This is a new function that observed equals false. All right. Not huge data, but still. Let's see how long this takes to run. Oh, right. I need to import. All right. So we're running our baseline pandas backend, and we're running time it on doing this complete aggregation. We're aggregating by 2 different columns. We're taking the mean, minimum, maximum, and standard deviation of all these numeric fields. And then we're unstacking that and filling all the empty values with 0. And we're seeing how long this takes to run. Okay, so 2.5 seconds. It didn't feel like that when I was running it before. Let's try to just run it here and count. 1 Mississippi, 2 Mississippi, 3 Mississippi. Okay, so yeah, it does take about 2 seconds. All right, so it's a medium-sized data set, but let's now see if this is any different when doing Pandas 2.0 with the PyArrow backend. Reset again. We're going to read it in like this. Read in like this. And do our time it again. So it's slightly faster when we did our last operation by using this PyArrow backend, but really not that much faster. If this is less than 2.5 seconds, that proves PyArrow backend does help in this situation. Ah, it's actually slower. That's surprising. Yeah, so the PyArrow backend, just to double check. Yeah, these are all using PyArrow operations. So actually a little bit slower. All right, now let's do it with polars. Similar to what we did up here. So let's do this. Copy this down here. Copy the polars reading of the data frame. Also this formatting. All right. And then we're going to have to run it similar to this. So we're going to have to rewrite this code in polars code because it's not exactly the same. I think we'll just need to do this. Actually, let me see if I can. No. Let's see if I can do this. Yeah. Oh, yeah. All right, so we do this group by with both columns like we did before. So we just add the two different column types, but this is where it gets a little messy, not messy with polars, but a little bit more verbose, because we actually, unless there's some way that I don't know about, we need to aggregate each of these values independently and alias their new aggregated names as something different. So you'll see here in a second, once I copy this long thing over. Okay. And it actually uses, instead of fill NA, it's going to use, we use fill none. It doesn't do the unstacking here. I guess the unstacking is built into this. Let's think. Okay, so this does the group by mean, min, max, standard deviation, and then unstack so that there's then a column for each of these provider, gender. Let's see if polars, does polars have a similar function as unstack in pandas? That I don't know. Saying it doesn't. There are ways to do this with a pivot table or by joining and flattening. One thing we could do is just take out that unstack. But I kind of want to just run this just to see what we're working with. Okay, the group by function needs to be underscore by. And it has no attribute fill none. All right, so I actually think this is fill null. Fill null. Okay, so let's compare apples to apples. Instead of using this unstack in our previous examples, let's remove it. That way we're comparing both the same sort of operations. We're not including the unstack because it's kind of a weird thing we would have to do otherwise. And I'm going to restart here. We're going to run this test number 2 with Pandas data frames. Whoop. Oh, syntax is not the same. Yeah, polars is a completely different library. So we're testing out a few different things. Pandas, which is been around for a while, has certain type of syntax that anyone who's used it before will be familiar with. Looks like this when you're doing your aggregations. Pandas 2.0 with pi arrow backend is essentially the same thing. So that we just ran this again. It was 2.58 seconds. So pretty similar to before. I reset my notebook. I'm loading it in now using the PyArrow backend, and we're running the same group by now with no unstacking. We're going to see how long it ran. Now, last time we ran this, it was a little bit slower using the PyArrow backend. PyArrow backend is supposed to be faster. So I'm actually, every time I've used it before, it was a little bit faster. So I was a little bit confused to see that. See if it holds up. But it could be something with the conversions, that a little bit of overhead for that. This data set's still not super small. Okay, so this is actually slightly slower again. All right, now we're going to reset. And we're going to do this in polars. This syntax requires a lot more writing, right? But when you're using polars, often you're trying to run big pipelines that you're going to be running on large amounts of data. And it's worth it to write it this verbosely because of this speed up. Look at that. 403 milliseconds. So we're talking about less than half a second, when in normal pandas, we're talking about 2.5 seconds. All right. So that's pretty good. Pretty good speed up. Yeah, like 1/5 of the amount of time. And then let's do pandas. And we're doing it with cuDF. So we're going to run it on the GPU. I have to switch to this environment. We're going to pull in our cuDF with the Pandas version, Pandas with cuDF backend. By running this load extension cuDF.pandas, it's going to run everything on the GPU. So then we should be able to do the same read parquet. And our same group by aggregation as Python or as Pandas. Pandas with PyArrow isn't supposed to be comparable to polars. It is supposed to, because polars in the backend does use PyArrow. It uses the PyArrow data types. And that's one of the benefits, is then when you convert it back and forth to pandas from polars, it's relatively quick because it's keeping the data all the same in the back end, but it's just kind of passing along a little bit of converted metadata. Okay, one thing I will notice is that reading this data in when we're using the Cuda version does seem significantly slower. So this makes sense, because just reading in the parquet file, now instead of running this and pulling the data into our local memory, we're actually pulling it into our local memory first, I believe, and then putting it into the GPU's memory. Or maybe it's just frozen. Maybe I did something wrong. We were able to load this okay before. So you can see here, this is where it's running and taking about 7 gigs of memory of compute on my GPU. What's going on here? Restart. It didn't do that before. Yeah, I see that it's loading in the data. It's definitely has some processing on the front end to get it into GPU memory. Maybe we just need to be more patient. Yeah, polars is written in Rust. So is kind of one of the differences. And I think the design principles that they decided when they created pullers was explicitly not to be a Pandas drop-in replacement. Almost exact opposite of how this cuDF version is working, because it's supposed to be a drop-in replacement where you just have to add in this one line of code. And then you're, boom, running on the GPU. Could it be that I'm running too much graphics stuff on this GPU? I don't know. Wow, it's taking a while. When we ran this up here, I don't think reading in this Parquet file took this long. And was I running the same cuDF version? Did I try to load it with the PyArrow backend when I was doing that with cuDF? Nope. Just read it like this. Oh, you know what it might be? Here, let's restart this. Might be the ordering of things. This could have an effect. Before we loaded Pandas after loading this extension, and that might be critical to what we're doing here. Yeah, that was it. Okay, so there's something weird with, if I loaded in Pandas after this extension, that it was freezing up. But look how it actually loaded in pretty fast after I fixed that. So two things I realized. This extension can't have this comment in it, which is a little bit annoying because where was the little bit annoying because in their example they have the comment shown here. So like basically, at least for me, adding in this comment at the end here caused this to break. And then also this needs to be at the top of things before I load in Pandas. All right, so let's do the timing. Let's see how fast it is. Let's see how it compares. Looking in the back end while this is running, there's my GPU. We can see that there is this cuDF Python running on the GPU. The compute is going a little bit higher. And it's probably running multiple iterations compared to what it was before. What size of the data frame? Yeah, just around 2 gigs. Not too huge. We could come back here and make an even bigger one if we wanted to. So is it struggling with this? Is it struggling? This is what happens when you test in real time. I don't know what the result's going to be. What is happening? Why is it taking so long? Here's still it running in the kernel. See you around. All right, you're heading out. Bye. 6,000 is still hot. Yeah. Could it again be something that I imported incorrectly, or did I write this okay? Maybe this observed equals false is a Pandas 2 thing. That could be it also. Let's go ahead and restart here. This is just, shouldn't take this long. Let's see if just running this without the time it function will work. Okay, so there it worked. It's a little quirky. It might not actually error out as well as it does when it's not running on cuDF. Okay, so there we got it. Once I remove that one observed equals false flag, which I think is a Pandas 2 thing, now it's running in 133 milliseconds. So faster than Polars, definitely faster than PyArrow backend. This is pretty good. Should we do a test number 3? This time we've worked out all the bugs. Let's do one final test to see what's fastest. I'm impressed by this though. 133 milliseconds is a good speed up. Should we just make a random data frame like someone suggested? All right, so I'm using my handy dandy chat GPT over here to give me some code to create a random data frame with 5 million rows and 10 columns. The columns should be date, time, integer, float, category, and string values. Make it large. I'm going to use this for benchmarking different data pipelines. All right, we're gonna create some synthetic data to make this even bigger. Which one do I use for work? Still Pandas? Most of the time. I have used Polars when the data is too large to fit into the memory of my machine. You're almost forced to use something like Polars, and it actually is pretty handy. But I might find myself, now that this cuDF Pandas exists, running this extension at the top of most of my notebooks. I mean, the downside is that you're then using an older version of Pandas. You also have to keep in mind that when you run this extension, if you're running anything else on your GPU, they're going to be fighting for resources. So if I'm training a model that's using TensorFlow or PyTorch, and that's also using my GPU, then that's going to be an issue. But as long as my GPU is free, you might as well use this. All right, it's really trying to give me a good example here. All right, test 3. $5 million rows. dates, float, int, etc. We're going to create it like this. All right, yeah, this should work. This should work. All right, so this is how we're going to create it. Why didn't I find it? Oh, I'm using this cuDF. You switch back to my normal thing. And see if this works. See the size of this data frame? We might want to make it even bigger if it's not going to fit here. And let's just do htop here to see what sort of resources are being used. I still have a good bit of memory left to be used. Here. Let's go with that. Okay, so our data frame is created. It's 348 megabytes. So let's make it a little bigger. What if we go by an order of 10 magnitude? So 50 million rows instead of 5 million rows. And we're going to save this as a Parquet file and then do some of those similar aggregations to it. Which OS do you prefer working with mostly? Is there an issue installing CUDA drivers? I've heard that Linux on Windows is actually pretty good, but I use just Ubuntu Linux for my local machine because I don't like dealing with a lot of the Windows stuff. I've given up on installing CUDA on my office Windows laptop. Have you tried the Linux subsystem? Because I've heard that's good. You've tried it and it still hasn't worked? Oof. Yeah, you can always dual boot with Ubuntu. And that's pretty easy. So this is chugging along. So what is this going to create? Float columns, category columns, random strings. This is exactly what we want. But just creating it takes a while. The things we do to benchmark. The things we do. What if I try some retro wave? Come on. Pandas data frames. Hey, thanks guys for following. I appreciate that. Hey, if you're following, you're brand new here, just let me know in the chat how you found my stream. I'd be interested to know. Be interesting to know how you even found me. Regards to polars being very verbose, couldn't you write a list comprehension to make it shorter? In itself, it's the same thing 3 or 4 times. Yeah, maybe. Yeah, this stuff could have been. I don't know if I've ever tried that though, like actually doing list comprehension within this list of aggregations. That's kind of an interesting idea. Of course, you'd probably have to split up like all the averaging together, all the minning together, because you can't get really complicated to do that in list comprehension. But yeah, this is all standard output. I think from a reading standpoint, it's a lot easier to read it like this because you know exactly what columns are being aggregated from this. List comprehension might make it tough to read. Was I a little too aggressive with the 50 million rows? Am I now regretting this? And I'm going to have to stop it. YouTube subscriber. Okay, cool. Just came from YouTube. Oh, nice. Welcome over from YouTube. It's taking forever. This is the thing about large data, is it takes a while. And that's annoying. Maybe I could have created this with polars. Maybe I could try creating this. Actually creating this with the cuDF. YouTube gang, Woodsy's boss. Welcome. Strings in time delta in Python. Am I transferring to super slow? Yeah, okay. So this is just slow and we know it to be slow. What's the size of it? 3.4 gigs. So it's not even that much bigger than our other one, but it is longer than it is wide. Like before we had 20 some columns, now it just has 10. So we're going to save this to a Parquet file. Is synth data.parquet. All right. To Parquet. There we go. And let's start to get stuff ready. So we're going to do Pandas. We're going to do Pandas 2.0 with PyArrow. We're going to do polars. And then we're going to do Pandas with cuDF. Right? If this will ever save. Let's see how big this is on disk for me. All right, so it's currently saving the synthetic data. It's already 4 gigabytes on disk. Probably done. Yeah. So it's 4 gigabytes on disk, 3.4 in memory. We're going to restart this bad boy. We're going to create some aggregations on this data, similar to like what we did before. So instead of running this on this Medicare data, we're going to run our synthetic data. And then we got to think of something to do with this. That'll take some time. First, we'll run a head command to see what we have. This is going to be like that. Polars is going to be like this. And then the cuDF version is going to be like this. And we'll have to change our environment when we run it. But we're pretty good with doing that. Man, this just reading it takes forever. I'm running a little low on memory. Did I reset this kernel? I thought I did. So it should have released all the memory that it was using from before. But yeah, I think it just takes a while to read this. It did take a while to save it. Sorry, what's the app used to observe the graphics card used? So I'm using NVTop. So I like using like top is kind of your command for seeing in Linux everything that's running. Then HTOP's kind of a prettier version. There's also BTOP. Lets you know all the stuff going on your machine, all the processes being run. And then NVTop is kind of like an NVIDIA GPU resource monitoring system. Read in polars maybe? Well, eventually we're going to have to read in Parquet. Okay, so we got it here. We can see how big it is. It's very big. 50 million. Let's do a group by, actually, date, time, and unique. 7,671. Okay, so we can do a group by this date time. And the category. And then we can aggregate like this. Let's do this. Aggregate. We can give this a dictionary. So the float, we can take the mean, min, and max of. Integer, we can just take the average value of. And then let's just see what this string, if we can do the number of unique. I don't know if it'll let me do this. And what we can do is do a head. Let's just make a subset of this, which is like first 1,000 rows, and copy that. All right, so now we have just a small data set that we can test this out on just to make sure it works. And it doesn't. Key error, date time. Date time, the time is uppercase. Maybe that was my issue. There we go. This observed equals true issue. String columns have the same values in each row. Yeah. We do a weekly mean and maybe get something like linear regression. Yeah, we could do that. All right, so a lot of these are empty because that category doesn't actually have an aggregated value for this date. Oh, I think our dates, yeah, I think you're right. I think that idea of doing something like the week. Again, I need to make this T in date time larger. Let's do day of week. All right, so we have a day of week now, which we will group by. We're going to group by this day of week, and then let's try to perform our aggregations. So now it's doing a date time operation, which might make it a little bit slower. And our aggregation will make a little bit more sense. So the minimum, maximum, and average float value, the average integer value, and then the number of unique string values. Random question, but any Python books you recommend? There's, yeah. None off the top of my head. String columns have the same values each row. No, okay. Is that right? They do. They do. That's fine though. This is kind of just taking up space. So we're seeing how long it takes to operate on a data frame that's a little bit larger. So it's basically like expanding this out for testing. All right, so we did this aggregation on our subset and we know it works, but now let's try it on our big one. because that was a pretty small data frame. We're running low on memory. See, this is actually becoming an issue. Because of these operations nested within each other, this stuff can really explode in your the memory usage. So I'm keeping my eye here on the memory use, because once this reaches, we've done this before on stream. Once that reaches 100%, then my stream will shut down. Then I'll be gone and you won't see me anymore. All right, DF aggregation worked. Okay, so it's the result is a very small file or small data frame, but we're testing how long it took to actually do those operations. So let's do time it on this. We don't need our subset anymore. That was simply for testing. We're going to do this from scratch. So resetting, reading in this data frame. Oh yeah, reading in takes forever. That's okay. And then once that's done reading in, I'll do this aggregation with the time it. Surprisingly, running benchmarks takes time. What's this book that you recommend? Python for Data? Yeah, anything by Wes McKinney is going to be solid. That's a good one. That's a good recommendation. I support that. All right, so reading in this Parquet file does take a while. But we're timing that separately than this aggregation, how long this aggregation takes to run. So while that's running, let's also just get this ready. Our next one's going to look like this. Then we'll run this aggregation here. And same thing with, we'll run it on Pandas with cuDF enabled. It's going to look like this. Hey Pookie, thanks for following. Let me know in chat how you found the channel. I'd be interested to know. Oh, it's taking forever. The memory use is exploding. How's it gotten bigger than what it had before? Oh, DF subset is not defined. That's because it's called... Oh, we did this wrong before. This should look like this. All right, moment of truth. Saw my Kaggle profile. Oh, thank you. Appreciate it, Pookie. Just a mere mortal. I am just a mere mortal. How long will this take? So this is going to look like that. Then I need to fix this one too. We're going to have to figure out how to do this in polars. So I'm going to see if we can get that pulled up while this is running in the background. What CPU do you have with 64 cores? It's a Threadripper. It's actually pretty old now. But yeah. Here's my profiler. Ryzen Threadripper 2990. Oh, my computer is starting to slow down. Oh no, we could be in for a tough ride here. We could be in for some turbulence. Hey, Manish, thank you for gifting the tier 1 sub. That was really nice of you. Now, are we going to be waiting here for an eternity for this to complete? We might just go ahead and skip the Pi Arrow version for now and see if Polars is comparable. This data is too big. Too big to do anything useful with mere Pandas. Pandas serves us well when the data is small. When it gets this big, we're getting into trouble. Come on! Come on! I genuinely wonder what the performance would be in regards to these operations on an M3 Apple chip. Yeah, that's true. It could depend on... I mean, everything varies depending on your hardware. Now, the thing about Pandas natively is that it's not doing any parallelized processing, right? You see that one thread goes to 100%, and that's typically the one that's running this computation. So see how the CPU is at 100% here for this process that I'm running? It should be able to go up to 6,400% and run on each of these threads if we actually wanted everything in parallel. And that's where Polars will kick in. At what point do I give up? I think the fact that we're running this DF on a subset before when we tested it, I forgot to change this DF time frame to not use this subset. So I think then it was doing the group by mostly on null values. Hey, what about those Google TPUs? Have you worked any with those? Like the Coral ones. I've used TPUs a lot, especially in Kaggle competitions when you're training a deep learning model. They are fast, but they're expensive if you pay for them. The cheapest way you can use it... Oh, look, it's done. The cheapest way is by using a Kaggle notebook. And then next up from that is actually using Colab and Colab Pro. So I paid for Colab Pro for a while in the thick of a Kaggle competition so that I could get those TPUs. But GPUs are pretty fast too. Okay, 36 seconds each time. So it ran 7 runs at 36 seconds each. Let's go ahead and reset everything. Let's clear out this memory use. Boom, look, down to 11 gigs of memory use. But we have our baseline with Pandas. Let's not do Pandas again, and let's try to instead do Polars just to see how this compares. Remember, reading in the data, just reading it in took a while with Pandas, but now we're going to do this aggregation, mean, min, max, mean, and the number of unique of the strings using Polars. And let's go ahead and time it. Oh yeah, that's right. Group underscore by. Okay, so there is no day of week. Maybe it's like this. Polars get day of week. Okay, so I think it's dot weekday. Little bit different syntax there. But okay, let's look at my CPU usage now with Polars. 64 threads. We do see it's running at about over 1,000% CPU usage for this one process. Because Polars is written in Rust, it can do that multi-threading. Man, it's done already. Polars, 3.48 seconds. 3.48 seconds versus the 36 seconds for Pandas. So this is why Polars can be so much more efficient when you have these big data pipelines with large data. We didn't even use the scan parquet, which could actually even make it faster. So there we go. A 10x speed up by using Polars over normal Pandas. But now we're going to try using the cuDF backend. No module named cuDF because I need to change to this. Let's see how this does. We're running now Pandas 1.5. Make sure we're doing the same aggregation as before. This took 36 seconds per run last time. Let's give it a try here. Oh yeah, this needs to be DF. You got to be kidding me. What? Seriously? Bam. That's so fast. Do you see that? Multi-threading on my 32 cores with Polars took 3.4 seconds, and that seemed like a pretty good speed up. Running on the GPU took less than half a second. Less than half a second for the same aggregation with our fake large data set. Let's just double check because I'm a little bit skeptical. Let's double check running. I need to go back to my other environment, my base environment. Running Polars. Let's look at our aggregated data frame once this is done. So let's run it like another time just so we get the output. And then we make sure the numbers are identical because they should be identical. Otherwise, we might have been running a slightly different process. But yeah, you could see GPU does speed things up. All right, DF ag. These are the results. I can even do 2 pandas, 2 string. Let's print this. These are the results from the Polars run. We should get the exact same. Let's do sort values by day of week. Should get the same thing-ish. Oh, it's not gonna, yeah, because we have to do 2 pandas first. Polars doesn't have the sort values. All right, this is a result from our Polars run. Let's try this again with the cuDF. GPU for the win. How much you spent on the Threadripper, if we might ask? It was many years back, but I remember it being multiple hundreds of dollars. I don't remember if it was more than 1,000. All right, timing this again just to make sure that it works. Okay, under half a second. Still kind of amazed by that. And let's do reset index. Slightly different. It's already sorted. ToString. And let's print this. Let's compare side by side. All right, so this is polars. Let's just take this print out here. I think the days of week are, it looks like with polars it's sorting by, or its values from 1 to 7. And here it's 0 to 6, so let's just eyeball it. Are the values the same? Everything's checking out for me. Check out for you guys. Yeah, it looks the same. All right, so there you have it. If you have a GPU to spare and you have some really computationally heavy processes. Now, keep in mind, the data still needs to fit in the GPU memory. So I have a large GPU here with 51 gigs of memory. If I used my 3080, I'd have 12 gigs. Still, this is around the size of data that's reasonable to fit into a GPU. You can't be using your GPU for really anything else. That's maybe one of the downsides. There's still a little bit of quirks with using it, but man, is that a speed up. If you have something and you're sitting there waiting for Pandas to run it and it's taking 30 seconds, consider rewriting it in polars, or if you have that GPU, using cuDF. That's my takeaway from today. Is there any other takeaways I should mention? Have I used DuckDB at all? We ran it on one stream. I tested it out. It's kind of cool. You can run some cool stuff on DuckDB, like SQL queries on files directly. Is it simply importing and loading cuDF? So the install, if you missed that at the beginning, it took a while. The main thing is having the hardware. If you don't have the GPU, you can't do this. You need to have an NVIDIA GPU with Cuda installed. Then follow the installation instructions like here to install Rapids. But then from there, yeah, all I had to do was this one-liner. Load extension cuDF pandas. And they do have this tutorial, I believe, on their GitHub that you can run on where is it? Colab, don't they have Colab notebooks? Yeah. So I'll put this in the chat. But this notebook would let you run it in Colab if you wanted to test it out. So you do have to install it first. But then Let's see where they run the command. Okay, so they're just showing an example using standard pandas. And then here's where they load the extension to actually do it. There's speed up in this example. You can see it takes 1.4 seconds here. 29 milliseconds here. Much faster. It took 5 to 20 seconds, can now potentially finish in just milliseconds without changing any code. I mean, that's great. That's great that they built it to just keep your existing Pandas code and it's just going to run faster. It's one more reason to have a big GPU. And sometimes I'm a little skeptical of this stuff until I test it out myself, but we tested it out ourselves and it worked here on my local machine. So definitely a huge speed up. Okay, thanks everyone for hanging out today. We did some good benchmarks. I'm going to try to make an actual YouTube video, full YouTube video with this just kind of quickly written down. But let's go ahead and raid someone. If you have questions, if you want to join the community, become more a part of it, you can always join the Discord. I believe if you do !Discord in the chat, or if you look on the YouTube video subscriptions, you'll be able to see that. Yeah, check me out on YouTube. All that stuff's at the bottom of the screen right now. YouTube, X, GitHub. I don't think I have my GitHub there. But we're going to go ahead and raid someone. So if you're on Twitch, you're going to be joining. Who should we raid? Who should we raid? Let's go to Browse, Software and Game Dev. Anyone doing Python? Any suggestions for who we should raid? Coding with Strangers, he's like, codes in Python, although he's not doing Python right now. Yeah, let's go ahead and raid Coding with Strangers. What's that? So rating, if you're new to Twitch or if you're watching on YouTube, rating allows me to send everyone who's viewing us right now to a different channel so that we don't just end here and have it be kind of like a abrupt ending. So we're going to all be moved over to Coding with Strangers very quickly here. But thanks everyone for hanging out, and I will see you guys next time. Let's make sure this worked. See, it should raid if I know what I'm doing here. Did it go? Are we over there? No, we're not. Okay. All right, let's do it. All right, I think we rated. I don't know. I don't know if we didn't. Yeah, it says I'm already rating him, so I guess I'll see you guys next time. Thanks for hanging out. Bye. Bye-bye.